Hello and welcome to another tutorial. We are going to continue our discussion with the static behavior of classes. We looked at the static state, which are static fields, a static behavior, which was the static methods, and we discussed the differences between static methods, non-static methods, and we said that you can, Java provides a static import for static methods. You can even import all of the static methods of a class and static fields as a wildcard, and then they are available in your source code in every class that you have in the same source code. They are available as global methods or functions, right? So you don't need to qualify them by like the fully qualified name of the method. Just like a class that has a fully qualified name, which means the class belongs to a package hierarchy, a method also has a fully qualified name, because a method belongs to a class always in Java, and then the class obviously has a fully qualified name. So the fully qualified name of a method is package, class, and then the name of the method. We said that this is tedious, therefore we can make the global static methods available as global functions in our Java source code. And again, this is the closest thing that we have as to freestanding functions in Java, right? As compared to the C++ or other programming languages like Python. Now, what is a static initializer blocks? Just like a class that we said that in the constructor, there are a couple of things usually happen that sometimes or most of the time we don't see it, or it's hidden. One is, first of all, what happens in the constructor. Let's see if we had, let's look at this class. Yeah, so we said that in this Tesla class that extends car, something happens, and that thing is that in the constructor of a subclass or a class, the compiler enforces that the state of the superclass, the non-static state, right, of the superclass has to be initialized before the subclass is created, right? So whenever somebody calls a new operator, the compiler has to make sure that, first of all, the superclass part of the subclass is created, initialized. That's why there is a call to the superclass constructor using the super keyword and whatever parameter. If the superclass has multiple constructors, then you kind of need to specify which constructor you want to call. And if the superclass doesn't have a default no-R constructor, or if it has it but it's private, then the compiler doesn't implicitly synthesize the call to the super constructor with no argument, right? That's what we said, and therefore you get a compilation error if, for example, you try to compile your class. Right now, this car class has a constructor. If I hover over this, it tells me it tells me which constructor of the superclass is called. And then, for example, if I pass an integer and hover over it, it tells me it calls the constructor of the car class that gets an integer. And if I hit the control or command and click on this super, it takes me to the constructor that is being called, right? So your IDE is aware of that. But then we said that after the super class is initial, so this call to the super class constructor is always the first line in your code, even if you don't write it, even if you have something like this, obviously we can't have duplicates. So let's say this takes an int, right? Even if I don't put anything here, the compiler will synthesize this call to the no-R constructor of the superclass. And again, if the superclass doesn't have such a constructor, you get a compilation error. But if it does, then the compiler automatically calls that, right? So this is, but then the next line is non-static initializer. Now what this means is that maybe you want to initialize some values when somebody creates an instance, and we've already seen this. For example, int x equals 5, right? First of all, you don't have to do this. We said that Java allows you to do this. So directly initialize the non-static state with some values. Note that when you have a non-static field, which is part of the state of the class, and you initialize it, when the JVM loads the class into memory, this x is going to be initialized to 0, its default value of the type. So when JVM loads a class into memory, x is going to be initialized to the default value of the type. In this case, it's int, which is, okay, int 0, right? If it was a reference type, it's initialized to null, which means all the bits are 0. If it's double, it's 0.0, which means all the bits are 0, right? This is a variable. It has some memory allocated. This variable is pointing to some memory in the Java heap, and all the bits in that memory based on the size of the variable are all going to be set to 0. That's the default value. And then when somebody calls the new operator, when somebody calls the new operator on a constructor, then JVM looks at the class file and knows which fields it has, and when the JVM creates, so when JVM actually creates objects, which means we've seen how the new operator works, right? It JVM allocates some memory in the Java heap for the non-static part of the state of the class, right? So this there is some memory allocated to hold the x value for this particular instance, and then JVM looks that this variable has a default value, so it's going to, and after that JVM puts basically 5 into x variable after the memory is allocated for this particular instance that we're creating, right? Now, as you can see, obviously all the instances are getting this default value, but because this is a non-static field, JVM defers initializing these until somebody creates an object, which makes sense. I mean, JVM is designed to be lazy as much as possible, so there's no point to put 5 if somebody never creates an instance of this object, right? But then what happens behind the scenes is that this code will transform into something else. So and it's called instance or non-static initializer, and it actually has a syntax like this: some scope. Remember, this is a scope, but this scope is not defining a method scope. It's just an extra scope in the global scope of the class. So this code will transform into something like this. Let's comment this out. Or so I'm going to keep it but rename the name. So instead of x, I'm going to say x1, and x1 equals 5. And the reason this happens, again, because when JVM loads the class into memory, it doesn't care if a non-static field has some default value. JVM is not going to initialize it to that value. JVM only cares about the type, and then when JVM loads the class file into memory, it sets all the bits of this variable. The memory that is allocated to this variable sets all the bits to 0, which means JVM gives the default value. And again, this is a guarantee the Java language specification provides, that all the non-static fields have to be initialized to default value. They are not allowed to have garbage value, right? Basically, non-static fields are not allowed to hold the garbage value in the memory. So JVM initializes all of these to 0. Sometimes you may argue that, okay, in C++ this doesn't happen because C++ doesn't provide this guarantee. Somebody has to initialize this. But then in C++ we saw that they introduced uniform initialization, which means in C++ you can request the compiler to actually do the same behavior that the JVM does. If you say int x1 but then open close curly braces, this means when you create basically always initialize this value to the default value that this variable to this default value that the type has, and which means set all the bits to 0. If it's a pointer type, it becomes null pointer. If it's an int type, it becomes 0, right? So with this syntax, it's more or less similar to what the Java behavior happens, right? So here we don't need to have curly braces. Java doesn't allow that, to have uniform initialization syntax that they introduced in C++ 11. But then the same behavior happens here, right? So the reason the compiler does this, again, because when JVM loads the class file into memory, a line of code like this is broken into 2 pieces. One is the declaration. When the JVM JVM loads the class file, it only needs to know the declaration of the variables, right? The non-static state. But then initialization happens here, and then what happens after this is broken? This code is actually copied after the first line of the construct. So the second line is the call to this instance initializer. So this line is broken into two pieces, and then this piece is copied right after the super call to the super constructor. So this is mandatory. The call to the super class constructor is mandatory to be the first line in each constructor. And then the second line is mandatory to be the instance initialization codes. So if you have multiple variables, int x equals 5, int y equals 10, what happens here is that these two lines are broken into, I'm going to rename the variable, so int x and then int y. I'm going to call them y1 to not get a compilation error. So int x equals 5 becomes int x, and then an instance initializer x equals 5. Int y equals 10 becomes int y, so the compiler removes this, and then y equals 10 in the instance initializer. And then the compiler copies all this code in the instance initializer and pastes it right after the call to the superclass. And this happens in all the constructors, right? I want you to really understand what's going on behind the scenes. And we can check that. So I'm going to comment all this out, comment x1 and y1, right? So right now in the source code, obviously it's much easier to write it this way: int x equals to 5, int y equals to 10. But then let's go and look at the bytecode, right? This is in the OOP, and then Tesla. Let's open this with a class file viewer, and let's have a look at the constructor that takes an integer, this one. So let's zoom in. All right. So as you can see, there is no code in the constructor, but there is a lot of code in the bytecode. A load 0 means load the pointer to this object, right? Remember, constructor can never be static. So the non-static methods, just like a constructor is like a non-static method, they always are passed this pointer, the memory address of this currently object, the object that is being created, right? So we say basically pass a pointer to this. Why do we need this? First of all, we need to invoke the constructor of the superclass, right? So the compiler puts this basically call to the no-arg constructor of the superclass. And if the superclass didn't have the no-arg constructor, we get a compilation error, and the compiler forces us to choose one of the constructor of the superclass that takes arguments, right? But in this case, in our example, this car class does have a no-arg constructor, so the compiler behind the scenes automatically synthesizes this line of code. So the first line of code in the constructor has to be a call to the superclass constructor. But what about the rest? It looks like there is nothing else, but there is actually some stuff happening. And you see, a load 0, this load this pointer, iconst 5, and then put field Tesla X. So basically what the compiler does is compiler says this dot x equals 5. So this line iconst 5, so a load 0, which means load a reference to this current object, iconst 5, that's the right hand side, and then put field x equals 5, right? So we load 5, now put it in this x field. Put field is a special bytecode for initializing the fields of a class that are not static. Okay, so it looks like there is nothing else in the constructor, but in the constructor, again, what happens here is that the compiler breaks this non-static initialization, int x equals 5, and then just puts an int x here. And as you can see right now, the field descriptors are int x. It doesn't say int x equals 5, for example. It just says this class has field x and y. And then when do they get initialized? They get initialized when somebody calls a constructor, which means they get initialized in all the constructor. Even here, x and y are initialized in the other constructor, also the same code, right? So these things happen behind the scenes because creating an instance of a class in Java has two parts. The first part, JVM loads the class file into the memory so that it understands what are the properties of this type, which fields it has, which methods, stuff, right? JVM needs to understand the type that you're talking about. And then after that, when somebody calls the new operator, JVM has to provide some guarantees. The superclass is initialized. All the non-static fields, basically non-static state, is going to be initialized. But JVM is lazy, which means it's not going to initialize the non-static fields unless somebody actually tries to create an object. And the compiler recognizes that. Therefore, it's the job of the compiler to break these non-static initializations into pieces and copies the defers the initialization to the constructor. Now, if we have a static field, this is not going to happen, because we said that the static fields get initialized exactly when the JVM loads the class file into memory. So a static int z equals 10. Now, this call for the z, you see there is no put field in the constructor calls, right? So where does that class, where is this static initialization or a static variable is going to be initialized? It's going to be initialized here, and it has a weird syntax. It's like so the static fields are initialized like this by push 10 and put a static. So we have kind of a different syntax for initializing a static fields, which is put a static. Instead of put field, we say put a static, right? Now, basically what happens here is that this is the job. Again, the compiler breaks this line into two pieces, a static int. So JVM only needs to know the declaration that, hey, this class has a property called z. It's a field of type int, and it's a static field. And then JVM, there's a difference between, for non-static fields, we had this instance initializer, which was just a scope, right? Now, if I say z equal 10, this gives me a compilation. It doesn't give me a compilation error, right? It still kind of works fine. But because this is a non-static initializer, the compiler will copy this code in the constructor. So when JVM loads this class into memory, z doesn't get initialized to 10. As you can see now, we have a call to in the constructor, we have this call. So compiler copies every code, any code that you have in an instance initializer into the constructor. So if I go back here and let's say in the main method, for example, if I say sysout tesla.z, this is not going to give me 10, this is going to give me 0. And the reason is that as you can see, it means z wasn't initialized through this instance initializer. So instance initializer code is copied into the constructors. So what if we want to make sure that this this static field is initialized to the correct value that we want? Obviously, the easiest solution is to declare it like this, right? And then JVM the compiler makes sure that this static field is initialized correctly. But there is another solution that's called a static initializers. So instance initializer is just a separate scope, individual scope in the global scope. But if you just add a static keyword here, then this becomes a static initializer. A static initializer, and this is used to initialize all the static state, all the static fields or state. And the compiler doesn't copy this static initializer in the constructor, because now this doesn't belong to any particular object, right? It has nothing to do. And obviously you can guess that in a static initializer you cannot have access to the non-static fields. If I say x equals to 1, this gives me a compilation error. It says that cannot make a static reference to non-static field. If I don't make it a static, I can initialize both the non-static and static field, but we can just say that it's a static initializer. Okay, so a static initializer happens, and you see in the code, in the constructor bytecode, there is no call to the z. We don't do anything. Instead, we have this static scope, which is the code for the static initializer. And this line of code declaring the z variable and then initializing it in a static variable is exactly equivalent to the first line of code that we had. Where is that? This line of code. As you can see, the bytecode doesn't change. It's pretty much exactly the same. So the compiler breaks this code down for a static initializer. It breaks the code down into two pieces. One is declaring the static and the other one is initializing them. Okay, because JVM needs to understand in two steps. One is what are the properties of this class when it loads the class file into memory, which means it needs to know what are the fields and what are the types, right? So we have X field integer, Y int, Y a field int, and these are non-static, and there is a field Z static, right? So JVM first has to understand this, and after it understands that, it realizes that okay, there is a Z field that is int, it's a static. Does it have any initializer or not? So it tries to look for a static initializer for a static fields. If it finds it, it executes the bytecode. So this bytecode for the static initializer will be automatically called by the JVM, and we can prove it, right? So let's look at the order of execution. So I'm going to have an instance initializer. Let's just do a sysout. Instance initializer called, and then in the static initializer, so I'm going to comment this out. I'm going to have this Z variable, and then I'm going to just say system.out basically a static initializer called. And after that, we're going to basically have a constructor. At the end of the constructor, we'll do a sysout on constructor called. Okay. Now what we want to do, so I'm going to close this up. We want to do, how do these get called? How the order of calling. So OOP, let's say, let's call this class a static initializer demo. Have a main method. All right. So when does JVM load? So JVM is lazy, which means it only loads a class file or a .class file into memory when it is necessary. And when is it necessary to load a class file into memory? When somebody tries to use a type, right? I'm in the same package, so I'm not going to use the fully qualified name of the Tesla. But let's say I want to do a sysout. Or let's say I want to say var x equals Tesla dot z. I want to access this z, right? And this z is a static field, so I can access it without calling the new operator. Now the question is, what happens here is obviously JVM looks at this code and realizes that Tesla is a type, is a user-defined type, and it tries to go and search for it. And the default is search for it in the same package as this source code, right? Otherwise, we had to have an import statement or use the fully qualified name. And it finds this Tesla type. So, and then what happens here is that, so step one, I'm going to write this step. So step one, look for this Tesla type in the same package. And once it finds it, step two, load the .class file of Tesla into memory, right? JVM loads it to understand what are the properties of this type. Before doing that, it's not going to do that because that's a waste of memory. That's why Java is really good for large projects with thousands of class files, because unless somebody uses them, they can be available on the class path, but unless somebody uses them, JVM is not going to do extra work to understand those types. All right. So this is when this happens, JVM has to provide some guarantees, right? The guarantees that JVM provides is that number one, or A, let's say guarantees. So guarantee number one is that all the non-static fields, are default initialized, which means all JVM looks at the type and then sets all the basically values to 0. 2 is all the static fields are initialized, or we can say all are default initialized. And after that, JVM looks at the if there is a static initializer, it will be executed. It will be automatically executed. It will be automatically executed. All right. So if we are accessing a static field, let's see what happens. What do we expect? We're accessing this static field and we have initialized that. So we have initialized it in a static initializer, and we said that if you directly write a static int z equals 10, it becomes equivalent. The JVM removes that, only keeps the declaration, the Java compiler, and removes the z equals 10 into a static initializer, right? So every class has one static initializer. Even if you have multiple static initializers, the code JVM, the compiler creates one static initializers and copies all the codes into that. Now what happens if one line of here depends on another line of here, and then if that happens, you get a compilation error, right? So you have to be careful, because the order of initialization is exactly the same as as the way you write it in the static initializer. So dependencies cause compilation error in the static initializer, so you have to be careful. But for now, we are accessing this z, so JVM has to guarantee that this z is initialized to the value that we want it to be initialized. So JVM has to call the static construct a static initializer. So let's see. So if I run this, a static initializer called, but I didn't do anything. I just tried to read this value, but because this value has a initializer, then the JVM automatically executes the static initializer, right? Now let's go back here and do it this way. Now obviously in the first look we expect that, okay, this z is not initialized in the static initializer. So let's see what happens now. Do we expect to see the static initializer be executed or not? And the answer is yes. Why? Because actually the compiler broke this line of code into a declaration and copied the initialization into the static initializer. The compiler did this, and JVM, when it sees that there is a static variable, it's going there is a static initializer available, it's going to always call it when it loads the class file into memory, right? So if you want to read a value, the static initializer is going to be called. That's one of the strong guarantees. Now the other stuff happens. So a step 3 is when you go and call a constructor. So a step 3, when you create an instance of the object using a new operator. Basically you call the constructor, and then the extra guarantees here is this. So extra guarantees that the JVM provides is number 1, or let's call it number 4. So this 1, 3 happens even if you don't call the constructor, you don't create an instance. Number 4 here is that call to the super class constructor default, or if your class doesn't have, you were enforced by the compiler to call one of the super class constructor. And number 5 is call to or execute. So all the code in instance initializers are executed right after the call to the superclass constructor. And then after that, number 6 is when the rest of the code in the constructor is executed. All right. Now there are one subtle things is that so the laziness, or what does logically make sense? The logically makes sense to, because static stuff is shared amongst all of them, and there is only one copy of this z in the memory. So the static stuff happens only one time, exactly when the JVM searches for this type and loads it in the memory. So if I say go down and say var x1 equals tesla.z, then we only see one call to the static initializer, and that happens here, right? Because the second call, it means all the static stuff has been already initialized, so there is no point to try to reinitialize them. So if I run this, as you can see, there is only one call. So all this static stuff happens only one time. A static initialization happens only one time. A static initializers only get executed one time. Only executed one time. That's when exactly when the JVM loads the class into memory. So if your class holds some resources, you can acquire those resources. Sometimes it's best to acquire them in the static initializer, for example, or sometimes it makes more sense to acquire the resources in the constructor, right? So it depends on what you want to do. So let's say var t1 is let's call the new operator Tesla, and then we have a constructor that takes a int, let's say 5. All right, so this is going to call this, and we only have one line of code, constructor call, and now we have a clear understanding that a lot of stuff happens before we reach this line of code. So let's see, and let's see what is our expectation. Our class has a static state, right? A variable that is a static state, and we initialize it. We wrote z equals 10 like this, and we also put some extra code in a static initializer. All right, so I'm going to comment this out. Let's see what happens right at the moment we call this constructor. First, new operator, which tells the JVM go create an object of this type. So JVM has to search for this type first and then load the class file into memory. So all this stuff is going to happen. Static fields are going to be initialized, default initialized first, and then the static initializer is called if there is initialization for the static methods or static fields, or we have some extra code, we have manually created a static initializer. And after that, the superclass constructor is called, which is car, and here we are, let's copy this, and this one takes so we are going to the car class, and in the one that takes no arguments, we're going to print this car no arg constructor called. This will be called, and after that all the code in the instance initializer is going to be called. So let's have an instance initializer, which we already have, instance initializer called, and after that you're done with initializing stuff. Now the rest of the code that the user has put here. So let's run this and have a final look at this. So a static initializer called, and know that this call happens before calling the superclass constructor, right? So let's also do one more thing. So Tesla, this is for the Tesla class, and this is Tesla constructor, and then Tesla instance initializers. I'm going to do the same thing for the superclass, which makes it more complicated. So let's say our superclass has some instance initializer car, and then our superclass has some static initializer, and it has a constructor, right? So let's see what happens now, and I'm going to quickly tell you what happens. Before when JVM sees this type Tesla, it looks for the superclass type. So these guarantees also, before applying to the type itself, these guarantees apply to the super type first. The above guarantees first apply to the super type, because if the super type has some static state, they have to be initialized before even talking about the subtype, right? So let's run this. All right, so first JVM sees this Tesla, and it searches the type hierarchy, the class hierarchy, and realizes that Tesla has a super type, which is car. So it goes and loads the car the class file for the car into memory. So car.class gets loaded into memory, right, by the JVM, and then all this stuff happens. The static initializer of the Tesla is called. First of all, the static initializer of the car class is called because the class file was loaded into memory, okay? And then after that, JVM loads the subtype, the Tesla class, into memory. So Tesla.class gets loaded into memory, and this immediately invokes triggers the execution of the static initializer, right? And then we go to the constructor of the Tesla. the first line is the call to the superclass constructor. So so basically what happens here is that, very interestingly, as you can see, the instance initializer of the car is called, and then the car constructor is called. The reason is that in the superclass, which is called, the compiler realizes that, or the JVM sees that car doesn't have an explicit superclass, and so its superclass is object, and object constructor is doing nothing, right? So we know that there is a super call to the superclass constructor. In this case, it's object, and after that, we know that instance initializer code, instance initializer code is executed. So this superclass constructor, we're not printing anything out, but we know that right after this, the instance initializer is called, and then the rest of the code in the superclass constructor, which is constructor car constructor, is called. And now we go back. This finishes up the initializing the superclass, right? It's instance initializer, the rest of the code is constructor, and now we go back and execute the instance initializer code for the Tesla class. So instance initializer is called, and finally we're done with everything, and now we execute the rest of the code in the constructor of the subclass, which is Tesla. So I hope you really understand this. If you have a problem, definitely review this concept, play with it, and maybe even create a deeper type hierarchy like car, Tesla, and then another class, Tesla Model 3, and then look at the order of execution. Normally, we don't care that much about this kind of stuff unless there is a special code in the static initializers, and then we have to be careful how this happens. If one important use of static initializers are loading dynamic libraries. When using, for example, JNI, Java Native Interface, this is one of the most important use cases of static initializers, because as soon as somebody creates a type, or the JVM loads the class file into memory, you want to load that dynamic library so that the JVM is able to call some of the native methods. These are more advanced topic and out of the scope of these lectures. So I hope you really enjoyed this. The last point is what happens if we create another instance. At this point, the first line loads the class files into memory, so the second call doesn't load the class files again because JVM already is aware of the types. So none of the instance initializers are going to be called. So they're going to be called only one time, the very first time the JVM loads the class file into memory. So let's do a sysout and then a star. So in the second call to the constructor, we only going to see that the state of the superclass is initialized, and then the state of the subclass is initialized. There is no call to the static stuff in the second round, right? The call to the static stuff happens only the very first time JVM loads the class file into memory. I hope you enjoyed this. Please stay tuned, and I'll see you in the next one.